When running simulations and trying to color your crystals correctly, it sometimes can be quite difficult to work out which face of your crystal is which. For cubic systems it's relatively easy, but even when you've just got quite high index faces in cubes, it's quite hard to figure out which ones are which. And when you start moving over to trigonal systems and hexagonal systems, it gets even harder. So I personally find it helpful to have a visual aid to help me work out which crystal faces are which. So I've run a simulation here on barite, and I've used the facet find mode to color the crystal as best as we can do. It's done quite well on the sides, but even there you can see there's a bit of overlap in the layers, and you can also see that it's colored the corner as a facet. On the top surface you can see there's a lot of overlap in the layers too. So if I just have a quick look at the facets found file, you can see that it's got a lot of facets. It's got 16, and a lot of them are copies of the same index facet, but they are the D spacings that are halfway between them. So you've got all the way from 001, which will be the top face, all the way down to 004, which is quarter of the spacing of the 001 plane. Now looking at this file, it's fairly easy to pick out which facets are which on barite. So we know that running along the Z direction, as we know barite is an orthorhombic crystal, the angles in the unit cell are all 90. So the Z direction, those two faces should be the 001 and the 00-1. But the side facets are a little bit harder. If we didn't have the facet found file, it'd be quite difficult to work out which ones are which, but you can kind of guess based off the only other angular one that's present that they're the 210 facets. But I'm just going to show you a tool which might be useful to help you identify which ones are which. So this software is called VESTA. It's got quite similar things to Crystal Maker, so you can add things like lattice planes in. Pretty much everything that you could do in Crystal Maker, you can do something similar in VESTA. But the key feature I want to show is the Crystal Shape tool. So what this lets you do is to build a small kind of polyhedral model of your crystal around your crystal structure. If you go to Edit, Edit Data, click Crystal Shape. It's essentially just placing lattice planes at different distances from each other, but I just find it is quite a useful tool in some scenarios. So if we add a new plane, and we'll put in the Miller index of 001, and press apply, you'll see nothing happens on the screen yet. That's because you can't form a crystal with just 001 planes. If this was a cube, it would work and it would show a cube, but the planes are not symmetrically related in an orthorhombic crystal. So the 001 is not the same as the 010 or the 100. So we need to add in some more faces. So we know from our file that the 210 facets are present. So if we add these in, press apply, we end up with quite a nice looking rhombic structure. But let's try colouring these slightly differently to distinguish them. So you can select the planes that you want and you can choose a different colour. So we'll choose one of them as red and we'll choose the other set as green. Press apply. And you'll see that it doesn't actually change the colour, but that's because we need to click custom colour on the crystal shapes colouring over here. So now we have a nice rhombohedron with the 001 facets coloured in red and the 210 facets coloured in green. But you can see it doesn't quite look the same as the crystal that we grow in Crystal Grower. This one is a lot thinner in the 001 direction. So we can actually account for that in VESTA by moving the distance at where these planes appear. So this D spacing here defines where your plane will appear. So the closer it is to the origin, the larger the face will be because it will cut closer to the origin. It's defined in terms of D spacings. So if we lower this down to 1D spacing, can see that facet got a lot bigger and the other one's got smaller. So we can do the same again. We should put it down to 0.5. Press apply. And you see now we've got a lot thinner crystal. It's getting more to look like a plate. We can then reduce it even further to a quarter. And now we've got a very thin plate. You can scale these up to make a larger crystal if you want to look at a larger area, but it's quite a useful tool for working out different facets that correspond to each other. Another useful feature is that you can disable the addition of the symmetry related planes and add them all in individually and color them individually. So I'll add in the 0, 0, -1 now that we've removed it from being symmetry related, and you'll see the shape won't change, but now we can set a different color for this plane. So let's make this one blue. Press apply, and you can see now the lower face has changed color. So this also allows you to differentiate between planes that are in the same set, which can be useful for your layer coloring too in Crystal Grower. If you align the crystals along the same axes in each visualization software, then you can make direct comparisons between them. Again, helping you figure out which facet is which, to change the number of layers or change the offset on, as these can sometimes be asymmetric when you're growing your crystal. Now let's try the same for the 2 and 0 facets. So if we stop the symmetry related ones from being shown, press new, we'll add in the -2, -1, 0, which is the opposing face. You can see our crystal's now disappeared because you can't form a crystal with these facets. We'll set that one to a different color. And then we need to add the other 2 facets, which will be the 2, -1, 0, and the opposite one to that, which is the -2, 1, 0. And we can assign these all different colors. So we'll give that that one's green, so we'll change that to yellow. And we'll change this one to orange. If we press apply, so you'll see it's formed the wrong crystal there, but that's because I didn't type in the correct facet. It should be the -2, 1, 0. And now we have our original crystal back, but each of those planes is colored differently. There are many other features in VESTA, but I find this one is really useful and missing from other software. You don't have to use this. There's a lot of other ways to work out which facet is which. You can simply run multiple simulations where you change each facet individually to work out which one's which, but I find this can be quite helpful sometimes.